And it could be, just also to go back, it could be a problem on Linux if you did use a case insensitive file system, which XFS or at least X4, you can turn this on.
Not by default, for sure.
Yeah.
It's not, but
Yeah,
I'm sure you can turn it on a lot of things. You can actually make a Mac file system case sensitive, or at least you used to be able to. And it's great at breaking everything. Hi, welcome to the G Research Open Source Software Outreach Podcast, the Gross Out Podcast. I'm your host, Jay Faulkner. And, you know, when I started this podcast, and really when I started this job, I had remembered reading a blog post about a really crazy set of security vulnerabilities in the terminals. And we'll talk about this during the podcast a little bit. But the cool thing for me is when I found out the author of that blog post worked right here at G Research Open Source Software. And ever since then, he's kind of been on the list of people I wanted to make sure that I got a chance to talk to in this podcast because it's so interesting to me. So everyone, meet David Ledbetter. David, why don't you tell the world a little bit about what you do at GR-OSS and kind of maybe your history in the open source and security communities?
Yeah, thank you. So I've always been very involved in open source in general, and sort of that was my introduction to kind of the world of computing. I think when I was like about 12 or something, I started writing Perl just because I'd found Linux, which was actually came on a cover of a magazine, and I was very excited. I remember like reading in detail the magazine because actually I was at a friend's house or something, so I couldn't actually use the CD yet. So I was really excited that I was reading how complicated it was to install Linux and all that sort of stuff. So I kind of got into that, and then that was sort of distracted me a bit from school for a while, but I think I learned some useful stuff in the process. And then, I found Perl, and then I started writing programs in that. And then I sort of realized, there's this whole community behind it. And through sort of the Perl community, I then got myself a job that was doing Perl stuff, which turned out to be for a very, very early cloud computing company that did email security. So I sort of accidentally found my way into the security space. But also I kind of already was interested in sort of that side of things as well. So I've always sort of been on both the security side, but also as a software engineer. So I then sort of did software engineering as a degree. And before you know it, I was then actually a software engineer, but I've always had this interest in security. And so I'll maybe skip over a few bits, but I worked at Google for a long time as a site reliability engineer, which at the time, they told me what SRE was and no one else knew what it was. Now they've sort of introduced that term to the world. So maybe we later could talk a bit about some of that stuff as well. But there's a lot to talk about. So anyway, security has sort of always been a side interest. And then G-Research offered me this role that both sort of combined security and open source stuff, which kind of I felt was perfect for some of the things I've worked on. And as you said, the terminal security thing was one of the results of spending a lot of time staring at random things and finding some sort of interesting, quite arcane security stuff that then led into, actually, there's modern bugs that relate to this in things like Windows Terminal that, Microsoft have embraced open source. And that actually means that there are, unfortunately, security holes that were quite old in some form, but they were in new bits of code, which is a theme that I think some of my security research is like, okay, there's these old things that people have forgotten about. Should we go and find things like that? And that's one of the themes that I sort of pull on a bit and can sometimes find interesting vulnerabilities that other people haven't. But I've kind of just dived into vulnerabilities there now. So I don't know where we want to go from there. But
it was interesting to me to hear that you started out your career in email security. It makes me wonder if at any point I was an adversary or a customer of yours, because actually the very first job was an email marketing startup I worked at that I left when it came clear they cared more about incoming funds than they did about abuse prevention.
I mean, it's funny you say that, because one of the one of the parts of the product I worked on was the literal bit of code that added the very annoying banner at the end of the email that said, "This was scanned by Message Labs email security services." And you may have heard of Message Labs, who were then later bought by Semantic.cloud. So yeah, if you saw that banner at the end of an email, then unfortunately I was the person who wrote the code for that. And there's some interesting stories there because, product managers were like, "Can we make this banner more offensive?" And I'm like, no, we cannot. Like, theoretically we could, but we are not doing that because we'll piss off our customers, and I'm not going to let you do that. So well,
it's interesting, just in a weird way. It always feels arcane to be talking about email because it used to be such dead center in the tech landscape, in like everyday life. And now I feel like email is sort of like regular mail, where the only things you get in it are like ads and bills. But that's
unfortunately, bad second factor auth that is maybe not very effective, depending how you consider it. But yeah, email is now a transactional thing that is not actually how you discuss things with people. I mean, this is actually interesting because some of the open source projects that I work with still use email. So if you've ever tried to contribute a patch to the Linux kernel, you basically have to have a working old school email setup, and there's no other way to do it. I mean, you kind of can, but there are some fun things there. Like if you have a Google account that has the advanced security stuff on, then you can't use application-specific passwords. So you basically have to jump through hoops before you could even use the SMTP client to Google to send email. So it's like, you want to submit a patch to the Linux kernel, but you've got this weird option on your Google account that makes it more secure. How do you actually do that? Well, yes, it turns out you have to jump through a lot of configuration hoops, which, to be honest, if you're capable of writing code for the kernel, then that is not very high a bar to jump, but it's an annoying bar that shouldn't be there, because it's like 20 minutes of setup even for someone like me potentially to make that work.
I just have this vision in my head of there being an issue open somewhere where people are begging them to implement OAuth and get send email, and that makes me kind of laugh a little bit inside to think about that. It's like, I can't send it unless you OAuth.
Yeah, I mean, maybe that, I don't actually know, but I haven't looked at that for a little while. But maybe that is.
I mean, a lot of stuff does doable, now.
But yeah.
Yeah, I was pleasantly surprised Fun Thunderbird does that. They'll do the OAuth handshake with your provider and manage it these days, which is a lot better than application passwords, which really don't exist anymore. But let's get out of the realm of the aughts, and let's move ahead to 2025. Well, actually, I guess we're not moving all the way ahead. Let's talk a little bit about security vulnerabilities and like the process of finding them and reporting them and stuff. Can we maybe dig deep into the terminal vulnerability I was speaking about earlier? Because you said you learned it by spending a lot of time staring at stuff. I mean, I read a lot of code, but I don't find ways to arbitrarily execute code in someone else's terminal. So like, how does that process start? And really the thing I'm curious about is like, what's the first clue? What's like the first thing you saw that made you go, there's something there's smoke here, right? There's a problem here that needs to be gotten at.
Yeah, so it's funny, the terminal one, it was actually a set of vulnerabilities, and it obviously, I can't actually, I have to go back and look at notes. I can't remember which one I found first now. I think it might have been the Windows terminal one, just because that is closer to the software that we care about as a company. But the actual sort of thing that made me start pulling on bits of string was not a problem in a terminal, but a problem in some code that runs in a terminal. So kubectl, which is the command line tool for Kubernetes, had a problem where it didn't escape certain escape characters in the output. And so when you ran a command, it could accidentally mess up the screen. And I think that was one of the initial bug reports, that someone said, this is messing up my screen because I've got some weird character in one of my Kubernetes manifests. And so then looking at that a bit more, they said, actually, this could be a vulnerability. And then a security researcher came along and said, actually, this is a vulnerability. And he worked for Ava, I think it was his name. I'm probably pronouncing that wrong. But he worked for an Israeli security company and basically found a bunch of vulnerabilities where you could do denial of service attacks through terminals. So the one that he did was change the title a lot of times, and that obviously means that the window has to be updated in the window UI, and particularly in Windows, there was a bug that if you updated the title too much, then it would just get a bit unresponsive because Windows was busy doing other things as a result of updating the title. And so that was the sort of first inkling that there was some problem. Was not me finding something, but someone else. And all credit to him as well for sort of starting looking at that. But then I actually had a discussion with him. He was like, "Yeah, the holy grail obviously was to find remote code execution, RCE, as it's called." And he was like, "Yeah, you found it. Well done. We spent a while looking for that, but this is actually an interesting thing that it took me quite a long time to find this. It was I knew it was possible. There was a lot of history to be read. There were lots of other sort of many previous people had done research into this. And actually, at the end of the day, a terminal is not that complicated. Like a web browser has many layers of things going on, and a web browser is doing a similar thing to a terminal. It is receiving some content from a remote system and rendering it. It's just what a terminal renders is quite simple, really. It's just color codes and some other bits and pieces. But it obviously doesn't have JavaScript and all these crazy things. So the attack surface is quite small. But even in that small amount of code, there can be bugs. But actually, how I looked for the bugs in the end was just reading the source code of the terminals. So it's like you have in your mind, there's an attacker here who can make any input to the terminal. What happens if they do this? And it's almost trivial to find sort of denial of service attacks. And I kind of just stopped reporting those at some point because some of them don't even matter. And I think this is another sort of difficulty that maybe we could talk about later, is what's actually a serious security vulnerability and worth fixing, and what's not. And even some of these terminal ones where technically remote code execution is possible, there are mitigations that mean that actually it's not really an issue, which is another sort of discussion. But anyway, I'll let you get a word in now, I think.
I mean, security wise, we talk a lot about threat modeling, and like that's kind of the idea, right? I think at least from the other side of the equation, because I'm an OpenStack VM team member, I'm the Ironic security liaison. I'm the one who would get your vulnerability report if you found one against Ironic. Feel free to look. Love to fix them. So it's kind of interesting because I think about how in security we talk about threat modeling, right? And how it's important when you're reporting a vulnerability, not just to think about what's theoretically possible, but also think about who can do it. And that other half is important. And the access to print things to your terminal is not necessarily like the easiest way to get stuff to get access to a person, right? Like if I've already got you to run a command in your terminal, haven't I already won some of the battle there? Like that, it seems like threat modeling a problem around consoles would be very difficult to find something really scary there unless it was combined with like a backdoor in a common open source project, something like that.
Yeah, well, it's funny you mentioned backdoors because the exploit, or however you want to say that, the unknown person who added some very interesting code to the XZ or XZ, depending whether you're British English, the compression library. They basically got very strong trust from the project maintainer and went and added some very interesting code that hid itself in some test data and then did all sorts of quite clever things. And then they were trying to social engineer things, like they were going to package maintainers being like, we really need to get this update into this release and so on. With the abusing a dependency chain into SSH was the end goal, so that it became an attack against SSH.
They got through libsystemd, right? They went through libsystemd on platforms that compiled that through. We actually, in Gentoo, that's a non-default configuration, so we actually dodged it a little bit there. But that's
it was a Debian specific patch as well, so it's not in upstream SSH, and there was a whole discussion about that as well. So whether you should, if you patch software and you introduce security problems, that's then on you, which is not the first time Debian have introduced security problems, which I don't mean in any bad way against Debian, but you have to be as a maintainer and packager of open source software, you have responsibilities, and one of those is making sure you don't introduce new security issues, ideally.
I like the folks at Debian. They go a lot of good work, but I've also rotated hundreds of SSH keys as a result of their patches in the past. So it's hard to say, but I do want to kind of challenge a little bit. I want to understand this, right? And I'll go with XZ utilities. I actually think Z is a way better term for the letter Z. Let's fess up to it. It's fine. But XZ utils issue, it's telling that they didn't have to worry about if there was a terminal exploit to get someone. Once you're running the code on the system, you've already got a lot of routes in. So like, I can sort of see the approach of this maybe not being that scary, especially from a denial of service standpoint. Anytime you can get code to run on someone's system without them realizing it, that is inherently scary. But it seems like this is maybe like a secondary route to like mess with people's system rather than necessarily like a primary vector of attack.
Yes, definitely. So, but one of the interesting things there is, if you say backdoored an SSH server, you probably get onto some sort of server on the edge of someone's network. From there, if they're debugging that server, then maybe they run terminal commands on it. And if you can attack their terminal, then you can potentially jump onto another system. And this is like one of the key things that security people care about is from here, where can you go to? And that is something a lot of security people worry about, is not just sort of the trust boundaries between systems, but where someone can elevate privileges and jump somewhere else. And one of the attacks I found through the terminal stuff was if the user had SSH'd in, was actually the server could sort of kill the SSH connection and then run a command on their local machine. So that basically achieves jumping onto another system in reverse, which really breaks security people's minds, because it's like that should be the wrong way that the trust is going. It would probably be very noticeable. I never actually released it, but I had a prototype where it like disconnected and then it reconnected back in and hid what it did, which I showed to one of our internal security people. And they're like, "That's too scary." So the point is, sometimes this seems a bit too far-fetched, but things like the XZ attack have shown us the lengths that an attacker is willing to go to. And if you're dealing with probably a nation state or something like that, then you have to be aware of what seemed like an insignificant vulnerability on its own and a couple of insignificant vulnerabilities, when joined together with some people intent on doing damage, can be used to do a lot of things, which is why when you see a number on a security vulnerability, so CVE has a CVSS rating and it's got a number from 0 to 10, where 10 is it's really bad. If that number's sort of like 7 or above, then you probably actually care about that like straight away. There will be differences in what system is affected, and you can't just look at the number. But a high number you'll care about instantly. But the interesting thing about this, the kubectl vulnerability I mentioned before, was I think that was given like 3 or 4. And that's another interesting thing. There were other escape character injected into terminal vulnerabilities that people gave like 6 or 7. Like, no one quite knows what number to give these. And I generally actually agree it should be a lower number, because you have to combine it with something else for it to be a problem. But on its own, it's not a bad problem, but it could be something bad when combined.
I feel like that's more a failing of CVSS than it is speaking to any specific vulnerability. And I mean, I come from, I'm on the security team of a large, complex cloud project. You can imagine calculating CVSSs that cover all of our use cases. Like I always want to write like 1 to 9, because it's almost certainly there's a config that's not impacted and there's a config where you are just in big trouble. And, and it's hard to draw those lines. But the thing that I thought about, I was not thinking clearly when I was thinking about all the things SSHs are used for. That means that you could get someone by getting them to pull down your Git repository. You could hack someone's machine potentially with a terminal-based vulnerability simply by getting them to fetch a Git URL over SSH, which is not a difficult thing really to get people to do in a technical world.
Yeah.
I would not have, until this conversation, thought of connecting to a Git SSH session as allowing code execution locally, but it kind of does if there's any cracks at all on the surface.
Yeah. I mean, there's a few mitigations with SSH itself because it has the time of first use check where you see the pop up where it says, "Have you connected to this before?" And so what you should do when you see that is you should check, "Am I actually connecting to GitHub? Is if they said they've got a new SSH key?" What you actually do is you say yes, probably, without checking that whether GitHub has a new SSH key today or what's happening there. That's an interesting one. I've got some prototype attacks for that where you use a different host name for Git and then it attacks you through SSH. So yes, there are ways to attack people through that.
So, it seems like Git might be an easy, it might be a vector to sort of get code into places where you wouldn't expect or anything. When we were talking earlier, you referred to the fact that there might be a little bit of smoke over in that area of the open source world as well.
Yeah, so the Git vulnerability that I've found is an interesting one where if you clone a Git repository, it potentially can run code. Um, and so this actually builds on a previous vulnerability where if there was a difference in case, so in the file name, when you check out a Git repository, you have a .git directory. If you're on Windows, .git with capital letters is the same directory. But if you're on a Unix system, if you're on a Linux system, for example, then .git with capital letters is a different directory. On macOS, the file system is case insensitive, so it's the same as Windows in that that file name would be the same as with lowercase. So anyway, what you do is on a Linux system, you produce a repository where you've say got a .git directory, which is in uppercase, that is actually a symlink to something like .git/hooks, which is where the scripts that Git runs on different operations live. And so then what happens is through that, you basically make it such that when someone checks out a repository, it runs the Git hook that you just provided in your checkout. So it
Is
then
that
runs your code.
so on Linux? That vulnerability doesn't work, right? Because I'm looking for the dot lowercase git, or will I happily respect it case insensitively via Git code?
That won't work on Windows. And this is, to be clear, this is a previous vulnerability that was fixed. And the way they fixed it is they said if you have .git with any arrangement of characters, we'll just not allow that. So this is now fixed by at least that particular one is fixed. And they added some defense in depth as well. So there are a bunch of other possibilities which were limited. It could be, just also to go back, it could be a problem on Linux if you did use a case insensitive file system, which XFS or at least X4, you can turn this on.
Not by default, for sure.
Yeah.
It's not, but
I
I'm sure you
wouldn't
can turn it
recommend
on a lot of things. You can actually make a Mac file system case sensitive, or at least you used to be able
Yes.
to. And it's
Yes.
great at breaking everything.
Yeah. But anyway, so we said this wasn't a problem on Linux, but I happened to be looking at this because I was just doing a bit of looking at Git and some other possible vulnerabilities. And I realized because you can have control characters in file names on Linux, you can use the carriage return, which is not really used anymore. So this is going back to the early days of computing. Carriage return is like when a typewriter puts itself back to so if you've got a typewriter here, it puts itself back like that, and it's actually a physical movement. And then line feed is when it moves down a line. So
that's like the whack R in, or whack R whack in, instead of the whack in.
So CR is /R or backslash. So actually, so CR is actually /R and is carriage return. And then line feed is just the normal new line, which is /n. And so on Linux and Unix, traditionally, it's just a /n for a line ending. But on Windows, it's /r/n traditionally. And so Git has code that strips off /r/n. But because you can have a file name that has either of those in, you can make a file name that ends with a /r or carriage return. And then Git, when it reads its configuration file, will strip that off. So if you have, for example, a directory that is foo followed by a carriage return, when Git then reads that back from a configuration file, it becomes just foo. And because of how Git did validation, it did that validation on the point before it wrote that to the file. And then when it read it back, it didn't have a carriage return on it anymore. And so you basically bypass the validation and then caused confusion. And it would think it was talking about foo with a carriage return on the end, but it was actually talking about just the directory foo.
And I'm assuming the next step is replace foo with .git.
So you could do that, or you could just make foo into a symlink that goes somewhere. So there are multiple ways to put off this attack. But yes, basically, yes, foo with a carriage return or .git with a carriage return. Either of those things will result in some level of confusion.
So I doubt my audience includes many not Linux people, but the way most normal folks experience this line feed difference is in Notepad, which when I say Notepad, you got to mean old Notepad because they like updated it a couple months ago. But if you ever open up a text file created on Linux in Windows Notepad, just the new lines appear to disappear because they're only using line feeds and not carriage returns in line feeds. And so many Windows specific tools, such as the original Notepad, just don't know how to deal with them at all. So that's kind of a lot of people get involved with that. And it's crazy to think that that sort of platform difference can be a jumping off point for an attack. And it's definitely, it's always the stuff you don't expect. Sometimes that I'm sure that when that code was written, it's like we're just stripping stuff off the end of lines. It's going to be fine. It's no big deal. And then it's snake it down years later, and it's an issue. That is a common pattern that I've seen in the type of security issues reported. But you did raise an interesting point earlier, and I kind of want to dig into this real quick, and then we'll go and talk to you about maybe this is our gross thing in open source. I don't know if you've got a specific story, but I did want to comment on the idea of like a lot of security vulnerability reports being low quality. Like you sort of alluded to that earlier, and I think that we're seeing AI tooling sort of become the new automated scanner bug report, right? Like you get those security issues filed by someone who ran like a scanner against their installation and went, hey, I found 67 vulnerabilities or whatever. And it's like, no, I'm sorry, this isn't correct. We've had a handful of those, especially around checking like Python software versions and things like that. But the AI ones are kind of starting to get in that category as well. Like as someone who's actively found many of these vulnerabilities, is like one of the people who do this as part of your job, how do you make sure that your security reports are taken as serious and prioritized and don't get sort of lumped into that bulk pile of, stuff that people are doing to try to, get transparent credit or, point an AI tool at it or something of that nature?
I mean, I think the first thing is it's a bug report. Okay, it's a bug report done in secret, but as far as I'm concerned, I treat it just like I would treat a bug report. It's like very clear details of, short summary, what is the problem. Sometimes that doesn't actually even deal with the security impact yet. So it's like, this is the problem, as if you're treating it like a bug. And then an extra section that says the impact of this is that someone can do this. And then the best thing is a video, if you can do it. Just screen record however you've got an attack against it. And that's the other thing, that sometimes you're not necessarily sure that it can be attacked. And so if you're sending a bug report and you're saying this, I think this is a security problem, then to be honest, the maintainers probably aren't going to take that as seriously. And that is a thing you should just deal with. Like if you want to contribute to some of the bug bounty programs, if you can't show an exploit for it, they're not going to be interested and pay you money, which is a whole different discussion, because that sort of obviously fits in with open source in an interesting way, because a lot of the bug bounty things are more for commercial software or commercial services. But there are some bug bounties for open source. So it is possible Microsoft are quite good at it. For example, I've got a bug bounty for the Windows terminal bug. And so for that, I submitted it through Microsoft's bug reporting platform, made sure I had a video demo of here I am running a command. Oh, and look, calculator pops up, which is the traditional way of showing that you've got code execution. So if you can show a video where, you press play, you click around a bit and calculator pops up, whoever is assessing that bug is going to instantly pay attention.
I would. I've not gotten one of those. I don't know if OpenStack's ever gotten one of those. I've only been on the vulnerability management team for about a year, but it's you send me a bug report with like video evidence of you exploiting a thing, you're definitely going to get my attention real fast.
Yeah. But then the other end of the extreme is people running vulnerability scanners, and they just send you the output badly formatted. Particularly, certain companies are very bad at this. They'll say we need this soon. Our internal standard is that this is updated by whatever. And the problem is there are many vulnerability scanners, and particularly the people running these scanners are not running them on the source code. They're running them on the packaged binary product of whatever it is, usually. And so particularly with container images, that can have dependencies in like libc that maybe aren't even relevant to the actual code that the container is exposing to the internet. So it's very difficult to explain sometimes to people, no, we'll fix that as part of the normal upgrade process, but we're not going to worry about that as a serious security vulnerability, even though this CVE has a 6 or something. We don't see any way that is exploitable. If you want to show us evidence that code is even reachable, then yeah, we'll be interested, but we don't think that is a problem. And it's interesting because some tools are much better than others. So at least in Go, the Go VunCheck tool, which checks for vulnerabilities, there's a very clever thing of scans your source code, and then it also says, do you actually use the symbol that is vulnerable? So if your code doesn't call the function that is vulnerable, it can say, well, actually, I know the vulnerability is in these lines of code. It's in this function. You're not calling that. Therefore, your code is not vulnerable. And so, at least for this is on Prometheus, the monitoring server, which I'm a contributor to. So I've a few of those I've replied to people being like, I know your tool says it's vulnerable, but actually Go VunCheck says it's not. So that's a false positive in your tool. And this is interesting because the commercial vendors say, yeah, we're the best. And actually, at least for Go, the best thing to use is the open source tool that is provided with Go. I mean, there will be exceptions to that. And if you're not scanning the source code and don't have the source code, that's a different problem. But for open source, you can nearly always get the source code. So yeah, scan the source code. Don't scan the container and tell me that the container is vulnerable because, I don't care. But
I didn't even know that tool existed. That sounds very, very nice. I've been a Python developer for a large portion of my career, and sometimes I see tools like that and I get jealous of languages that are more strongly typed. So, well, we've sort of talked about it a little bit, but everyone who comes on our podcast, we ask them to share a gross out story of open source where just you've had a struggle or something bad happened or you couldn't figure something out. And, throughout a successful career, you're going to have lots of moments like that. And, part of what we want to talk about here is how you can get over them and how like even the best of us are going to make these kind of mistakes. So do you have a kind of a gross moment that you've experienced in open source to help close us out here?
Yeah, I don't know if I can actually think of a particular moment. I think some of the security stuff I've done, convincing people of the severity of it can be a problem. One of the things there is some of this happens behind closed doors, and that's a bit of a weird thing with security stuff. Even in open source, a bunch of it is on either private mailing lists or private places, and actually that's sometimes the annoying thing about this. It's like
that's
who's
pretty
actually
darn
involved.
Gross. Like that could be the story because it's like you're going back in time, right? Like we talked about earlier, you were referring to the LKML development process and get format patch and get send email and stuff like that. The times when I use get format patch and I use get AM when I'm uploading patches to embargoed security bugs. It's like you're going back in time 20 years with a lot of the tools. And I know there are some tools and code review systems that are trying to bake this in a little bit, which is a good idea. But I mean, it'll take forever to get there for the majority of folks. And in the meantime, that is definitely a pretty painful part of
Yeah, yeah.
being
I
a
mean,
developer in the security space.
I think that the good thing there is GitHub are actually doing very well for this. So if you have a vulnerability and then you report it through GitHub, if they have GitHub security advisories turned on, then you can basically get a private fork on GitHub. You just push as if it's a normal thing. So a few projects I have convinced them to turn that on just so that I can contribute patches back. But not every project is interested in that. And so it can then be a bit of a pain point to how to contribute this back. And the other thing is I have sort of unfixed security bugs that are potentially subject to embargo, but they're nearly a year old. And so, uh, some of that is on me. I have lots of things to keep up with, and I have to occasionally remind people to do stuff, including myself. But that as well is part of the great thing is obviously fixing security bugs can take some amount of time, but sometimes they take too long. I don't like to hold open source projects to deadlines, particularly. Like some security people, like Google in particular, have a very strict 90-day policy, and if you haven't actually fixed it by 90 days or given a very good reason, which they might extend for, they'll basically just publish it with like, "Here's our patch, apply it to upstream." There are a few cases of them having done that, which for us partly it's we're trying to make the open source ecosystem better and more secure. And us coming along as a small player and saying, "Oh yeah, we've just released this vulnerability without a patch," it doesn't actually help anyone. We don't have the clout of Google to do that. So I I I can't see us actually deciding to do this. So we don't have the ability to push people as an organization like Google would.
It's kind of interesting, and I think it borders on like an ethics discussion even about keeping bugs embargoed. We've had this sort of discussion in OpenStack before of, our standard policy in OpenStack, just sort of to context set, is 90 days from the day that the team intakes it. So like you might file the bug Tuesday. When I wake up Wednesday, that's when the timer starts, basically, just when we see it and update it. But we also have a policy internally that basically says if at any point we're fairly sure it's not going to get fixed before the embargo, or it's not being committed to be fixed before the embargo, that will open it anyway, because there's something ethically problematic about sitting on a security bug when you have not made efforts to fix it. And so I do have a lot of of respect for being kind of hardline about stuff like that, because we have seen in the history of computing. I mean, I don't have any examples off the top of my head, but you know, companies almost maliciously sitting on security vulnerabilities for years and dragging people along, and maybe even using like legal remedies to try to keep people from, talking publicly about something that this organization or project should have fixed months ago. So that is
Yeah.
that is definitely very gross. I think there's a lot of gross stuff in security, and one of the things I really like about working at Gross and with G Research is that they give us the time to do kind of the important things in open source that aren't always talked about so much. The gross security work that you do some of and I do a little of, or even things like this podcast and spreading the word, talking about the good stuff about is happening in open source. So as always, kind of at the end of these things, I like to always just say thanks to G Research for giving us time to do cool stuff like this, to work on open source. If you're looking for a job and you are in the Dallas, Texas area or in the London, UK area, G Research is hiring for all sorts of positions, technical, otherwise. Just go to gresearch.com/vacancies. That's going to be down in the description for on either the podcast app or in YouTube. David, is there anything that you might have to plug personally, like a blog or something that you might want to talk about before we let go?
Sure. So my blog is dgl.cx, which I have a bunch of personal stuff on, but occasionally the full details of the terminal vulnerabilities I found are written up there. Although there's a short summary somewhere on the G Research site as well. But I tend to put the more technical stuff on my website, so you can see that. And yes, thank you very much to G Research for particularly the terminal research. I kind of I spent a long time going to Alex, my manager, being like, "Oh, okay, yeah, we've got." I found another one, and then he's like, "Oh, okay, another one. Oh, and another one." I think the end of that blog post, there's kind of like 10 CVEs or something, which some of those were in sort of slightly tenuous bits of software. Like for the reasons I started looking at OpenBSD, which we don't use internally, but I use it personally, and I find it an interesting platform to use to research like this because at least for SSH, it's the upstream distribution or operating system that SSH is developed on. So there's a couple of bugs that I found in SSH that I reproduced on OpenBSD, so you can be sure, okay, it is actually a problem with this rather than a problem with anything else. But yeah, anyway, so there's some details of a few things like that on my blog if you want more details.
Yeah, I mean, hey, it is nice and it's good that we get to go spread this love throughout the OSS ecosystem, even if there's not a solid dark line to G research. I mean, it helps everyone if the open source community is more secure. And really, I mean, like we've both been open source for a while. Like you can use whatever words you want to use for it, reputation, karma, whatever. But people who are influential in open source will begin to notice if you do the right things and you aren't always doing them because they scratch your own itch. Like it's a good way to build up a little bit of clout and to really get to the point where maybe when GR needs some sort of major feature in a random open source project at the edge of the ML ecosystem, maybe you'll intersect that OpenBSD developer. So that's that's kind of the nice thing. And this has been the Gross Out podcast. Thanks so much, David. This was so much fun. I feel like I could have sat here and talked to you for 2 hours, but we've got to let you go. So
Yeah,
again,
well, maybe we'll do it again sometime. So
oh,
thank you.
absolutely. Let's mark it on the calendar. On behalf of David, G Research, everyone over here, thanks a lot. That's the Gross Out podcast. Have a good one.